Good morning, student. So today we are going to study reflection of a light at a plane surface by using Huygens principle. Okay. So let us consider here a plane surface Mn. Okay. This is a plane surface Mn. A wave front can see here RA and QB. Okay, this wavefront, let it incident on this plane surface. Then it get reflected as a wavefront. See, you can see this AE and CF. Let we call this as a CF are the reflected wavefront. Okay. So how this reflection takes place, that we are going to explain today. We are going to study today by using Huygens principle. So see, when the wavefront RA and BQ, okay, the incident, this wavefront incident bounded by the ray RA and BQ when incident on the plane MN. At the time, see, they are incident perpendicularly, right? At the time point, this ray RA will reach first and then this QB reach, right? So when RA come and incident on MN, then as soon as it reach and touches this surface, then the point A on MN will behave like a secondary source of light and start emitting the secondary wavelets. Okay, when the RA reaches and touches the surface A, at the same instant, what will be the position or the situation of this BQ? At that time, B is at this place. Let this instant be t is equal to 0. At that time, B is not yet reached the surface. Okay. So, the B will take a time to reach the C. Okay. Let the after time capital T is equal to capital T, the B will reach the point C. Okay. So, by the time this point A will send the secondary wavelets in the opposite, in this plane, okay, in the reflecting direction. Okay, so it will start sending the wavelet. Now see, the distance covered from B to C will be Vt if V is the velocity of light and T is the time taken to reach the C. Then Vt will be the distance covered by this point B to come to C. Then with the same distance, okay, the radius will be same. From the point A, we will get one, if you will draw one hemisphere of radius Vt, that will be the reflected wavefront you will get here. Okay. So, having the radius Vt, so this reflected wavefront will be AE. Okay. It will reflect in the direction of AE. AR is the incident ray, where A is your reflected ray, and the radius of this, if you will draw the hemisphere, then the radius is Vt, and if you will join the tangent, then you will get this as an envelope and this as your reflected wavefront. Okay, and as you go from E to C, this radius goes on decreasing. Okay, and when it will reach this point at the point C, the radius will be 0. Okay, and you will get a reflecting wavefront EC. Okay, so AB is your incident wavefront while EC is your reflected wavefront. Okay, so the radius of the wavelet emitted by the point A to C. Okay, it will start emitting this. Each and every point on this surface will behave like a secondary source of light and will start emitting the secondary wavelets. Okay, and the radius of this wavelet goes on decreasing from A to C. Okay, so the highest maximum radius will be Vt and at the point C the radius will be 0. And if we will join the tangent or if we will draw an envelope, we'll get a reflected wavefront EC. Okay, now in this way the reflection phenomenon takes place. Now let us find out or let us prove by using Huygens principle the laws of reflection. So which are the laws of reflection? First, the angle of incidence is equal to angle of reflection, and angle of incidence, angle of reflection and normal all lie in the same plane. So first let us prove that is angle of incidence is equal to angle of reflection. Okay, so for that we should consider this ray diagram. Okay, so from figure, so here itself we will consider from figure that AE is equal to BC because AE is equal to the distance VT having the radius and at the same time this distance is VT. Okay, then next to that if we will see the angle RAP is equal to I. The angle R, this is RAP. This is your angle of incidence. If you will draw this AP as a normal, AP is the normal, then angle RAP is angle of incidence. Angle of incidence is the angle made with the normal by the incident ray. Okay, if AP is the normal, then this RAP is your angle of incidence I. Okay, then as RA is perpendicular, see RA is perpendicular to AB. You can see here by the red mark I have shown. So RA is perpendicular to AB. Okay, and what we can say, therefore if RA is perpendicular to AB, then and if RAP is 90 degree, then this remaining angle will be 90 minus I. That is angle PAB. It is equal to 90 minus I. And also again AP, this AP is perpendicular to AC. AP is perpendicular to AC. Here it is shown by blue marking. Okay, so as it is again perpendicular to AC, means how we can write here that PAC is equal to, PAC include both PAB also and plus BAC also. Means this angle plus this angle. Okay. Now this angle is already 90 minus I. Right? This angle is already, we have taken it as 90 minus I. As this incident angle is I, then in this perpendicular 90 degree, this will be 90 minus I. Right? If it is 90 minus I and this angle is 90, then this should be I. Because the addition of this both should be 90. If you will add I, then I minus I will become, will be 0 and 90 will remain. Okay. So in this way, we'll get here the angle BAC is equal to also 90 degree. We'll call this as equation number 2. Again, we will see here. See all of you. See what we have seen. That angle RAP is equal to I. That is angle of incidence. Okay. And as RA is perpendicular to AB, then we will get the angle PAB is equal to 90 minus I. And also AP is perpendicular to AC. Therefore, the PAC is equal to the addition of these two angles, that is angle PAB plus angle BAC. Out of that, PAC is 90 degree. Then angle PAB will be 90 minus I plus angle BAC. Now this 90 get cancelled, remaining is I. So that's why we can write angle BAC is equal to I. So is it clear? So angle BAC is I. Now the triangle, let us consider the two triangles ABC and AEC. Okay, if we'll consider, come to again the diagram. A, B, C and AEC. These two triangles ABC and AEC. In this two triangle, this angle E and this angle B is 90 degree. Then AC is common to both, right? And again, this AE is equal to BC. That's why these two triangles are congruent to each other. That is by hypotenuse side theorem. Okay? And as these two triangles are congruent to each other, the corresponding angles of this triangle are also congruent. That's why what we can write here, angle ACE means this angle. Angle ACE is equal to angle BAC means this angle. Okay, these two angles, this angle and this angle, these two angles are congruent to each other. Okay, that is angle BAC and angle ECA. Okay, these two angles or ACE, these two angles are congruent to each other. Okay, so that's why how much is your BAC? We have already seen BAC is I. So we can write here ACE is equal to BAC is equal to angle of incidence I. Okay. So now what about angle of reflection? Now see, angle PAE is an angle of reflection. That is the angle made with the normal AP by the reflected ray AE with the AP. So this is your angle of reflection R. Okay. Now adds. Here again, how this is equal to R? Let us prove this. In this case, angle of reflection APAE is equal to R. Also, as AE is perpendicular to EC. AE is perpendicular to EC. And also, AP is perpendicular to AC. AP is perpendicular to AC. Okay. So, we'll see here. Once again, I will show the separate diagram for this explanation. You can see here, AE is perpendicular to AC, EC, and AP is perpendicular to AC. Okay, now we have already the angle of reflection APE is equal to R. And if it is 90 degree, then this angle must be 90 minus R. Right? Again, this angle is 90 degree as AE is perpendicular to EC. If this is 90 degree, then in this triangle AEC, addition of remaining two must be 90 degree. So you can write here 90 minus R. We don't know, suppose this angle is X. Then 90 minus R plus X should be equal to 90 degree. Then 90 get cancelled, means minus R plus X is equal to 0, means X is equal to R. Means this angle come equal to R. Okay, which is equal to angle of reflection. So how we can say angle PAE is equal to angle ACE. Right? So again, let us come to our diagram. That angle PAE is equal to angle ACE, and which comes equal to R. I is equal to R. So previously we have proved according to congruency in these two triangles, this triangle and this triangle, these two angles are corresponding congruent angles. So that's why I is equal to R is proved. So how we can write here? See, we'll get the two equation, that is ACE is equal to BAC is equal to I, and ACE is equal to PAE is equal to R, and therefore I is equal to R. That is angle of incidence is equal to angle of refraction. Okay, sorry, angle of incident is equal to angle of reflection. Okay, so this is the first point proved, first law proved, and also the angle of also the incident ray, then this normal and reflected ray. Okay, all lie in the same plane of the paper. Right? So we can say that is our second statement, that is all the three lies in the same plane, and also the incident ray and reflected ray are on the opposite sides of the normal. So all these three laws of reflection can be proved on the basis of hygiene principle. So student, try to write this explanation, prove this, and if again you have any doubt, once again if you want it to explain, let me know, we'll explain. And read it and try at home. Write the expression 2 to 3 times. Okay, bye.